Hello everyone, I'm Paul and today we're solving problem 2444, count subarrays with fixed bounds. So we're given an integer array nums and two integers min k and max k. And our job is to find the number of fixed bound subarrays. And these are the conditions for the fixed bound. So we need to find the number of subarrays in which the minimum value equals to min k and the maximum value equals to max k. Now to see how this works, let's say we have this array and min k equals 1 and max k equals 5. So for example, this would be a valid subarray because it includes 1 as the minimum value and 5 as the maximum value, and this will also be a valid subarray because the minimum and maximum values are the same. So given that these are the only subarrays that meet the conditions, the result for this one will be 2. Now if we look at the constraints, we see that nums.length is smaller or equal to 10 to the power 5. This means that we need to implement something faster than big O of n squared. And actually we can implement a short solution that runs in big O of n. So now let's see how can we solve this. Now let's say we have this array and this is min k and this is max k. Well, this means that, for example, this is a valid subarray and this is also a valid subarray and this is also a valid subarray. This one is also a valid subarray. This one is valid and this is valid too. So here we have 6 valid subarrays. Now the question is, how can we solve this in big O of n time complexity? Well, the first observation we need to make here is that we have some values that are out of bounds, meaning they are smaller than min k or bigger than max k. For example, 7 is bigger than max k and 1 is smaller than min k. So we know that these two values will never be part of any valid subarray. We also know that for a subarray to be valid, it must include 5 as a maximum and 2 as a minimum. So these two values are also very important. So we can actually keep track of the last time we see each max k and min k in our array and the last time we see a value that's out of bounds, such as this one. And with this information we can do the following. Let's say we are iterating this from left to right, and right now index is here at index 3. Okay, now we could take the minimum among the last time we saw the min k and the last time we saw a max k and subtract the last time we saw a value that was out of bounds, meaning 0 in this case. And the answer for this will be 2, meaning we can add to our result these 2. Now let's see what this means exactly. Well, for example, we know that this array is valid because it includes a 5 and a 2, and we also know that we could create new subarrays with every value in between the 5 and the 1, and all of those arrays will also be valid. Okay, so this one is also valid. That's why here we are adding a 2 to our result. Now we'll store these indexes in 3 different variables. We'll call the first one lasts out, which at this index is 0. We'll call the second one minimum, which at this index is 3. Okay, the last time we saw minimum k was at index 3, and we are creating another variable maximum, which here equals 2. and our result is currently 2. Now remember, we are iterating this array, so right now we are here at index 4 and we are checking the same as before. We want to take the minimum among these two values, 3 and 2, and subtract the last time we saw a value that was out of bounds, in this case 0. And the result for this is 2, so we add this to our result. Now our result is 4, meaning this subarray and this subarray are both valid. Okay, now we are here and we are adding to the result the minimum among 3 and 2 minus 0 again. So we add 2 more to our result, meaning this subarray is valid and this subarray is also valid. Now the I is here and this is the new last value that's out of bounds. So here we put a 6. And now if we do the minimum among 3 and 2 minus 6, we get a value that's negative. And in this case, we don't want to add anything to our result. And next we continue and we reach the end. So we return our result 6. Now the time complexity for this one will be big O of n, and space complexity will be big O of 1. So now let's go with the code and hopefully you'll get the idea. First we'll say result equals 0. Our variable last out equals -1. Minimum equals -1 and maximum equals -1. Next, for I in range length of nums. First, if we're out of bounds, we need to update our variable last out. So if nums at I is greater than max k, or nums at I is smaller than min k, last out equals I. Second, we want to update max and min if we find any min k or max k value. So if nums at I equals min k, min equals I. If nums at I equals max k, max equals I. And finally, we want to add subarrays to our result. So result plus equal our formula that was the minimum among the minimum and the maximum minus the last index of a value that was out bounds. And remember that if this is negative, we want to skip this. So one easy way to do this is to say maximum among 0 and all of this. And finally we return the result. This is the entire code, and now let's submit this and see if it works. And as you can see here, this works. So if you found this useful, please drop a like, subscribe, and see you next time. Bye bye.